Hi, this is Kumar Singh from Designed Analytics LLC, and you're watching another episode of Throwback Thursdays. Well, when we talk about artificial intelligence, the name that immediately comes to our mind when we think about some of the historical pioneers of AI is Alan Turing. We covered him, right? We covered his famous paper in one of the episodes of Throwback Thursdays, right? And he is universally recognized as one of the founding fathers of the AI domain, right? However, there is another intellectual giant whose contribution was equally crucial. Although it often received and is still receiving less attention in historical accounts, and that person was Claude Elwood Shannon. So while Turing laid the theoretical foundations of computer science, right, with his abstract machine that we covered in that episode of Throwback Thursdays and the famous test on machine intelligence, Shannon was quietly revolutionizing the way we think about information, communication, and ultimately the very structure of artificial intelligence. Well, born in 1916 in Petoskey, Michigan, his father was an entrepreneur. He had a furniture store, I believe, and his mother, she was a language teacher. So his intellect, this fusion of pragmatism and academic curiosity, right, it characterized Shannon's entire career actually, and it enabled him to move in an agile fashion between abstract theory and practical applications. His academic path was extraordinary, as you can imagine, right? So he earned 2 degrees from a really good University of Michigan, one in mathematics and one in electrical engineering, and thereby demonstrating from the outset an unusual ability to connect different disciplines, right? Now, I'll take a pause here just to ramble a little bit, right? You hear so much about like AI taking away jobs and like what are the skills that you should focus on, right? This is a perfect example of how, if you kind of, and we will touch upon this in a little bit detail later, right, with an example, but if you develop more like a generalist approach, right, versus becoming expert in something, that I believe will be one of the crucial aspects in the AI age, right? Because expertise in one specific field is something that can be taught, because the more expertise you develop in a hard area, right, defined by a hard set of defined set of knowledge, right, it's easy to teach that to an AI, right? But having a knowledge of a generic broad knowledge and the ability to interconnect them together is something that AI still kind of struggles with, and I assume it will for next few years. So yeah, that was the pivot, right? So basically we're talking that Shannon had this interdisciplinary interest, and it was this interest that became his hallmark actually, right? It led him to generate and give us revolutionary insights which are at the intersection of seemingly distinct fields, right? Now there's this web page on the University of Michigan website that I think very beautifully summarizes his place in the world of technology. So I'm going to read some lines exactly from this page, right? The modern world that we live in would not be possible without the work of Claude Elwood Shannon, right? Over his long and decorated career as a mathematician, electrical engineer, inventor and cryptographer, Shannon's theoretical insights led directly to the creation of digital circuits, advanced telephony networks, and the internet. His work was so ahead of its time. It was a challenge to even categorize in 1948. So those were the words from the website. But then, what was his work, right? If it was so ahead of its time, right? Meanwhile, like just another pivot, while going through the website, I saw the spelling of programming here might not be right, not be correct, and because it's a library web page, this should be corrected probably, right? So yeah, going back to what was his work, which was so ahead of its time, right? And how does this whole aspect of being interdisciplinary comes into play, right? So Shannon's first revolutionary contribution was in 1937 when he was still a student at MIT. Right? So after getting his 2 degrees from a great institution, University of Michigan, he went to another good institution, MIT. In his thesis, Shannon demonstrated how Boolean algebra, which was an abstract mathematical system that still operates on binary value, true, false, could be applied to electrical circuits with switches, right? This was groundbreaking. At that point of time, this was groundbreaking, and this groundbreaking work established a direct connection between mathematical logic and physical circuits, laying the foundations of modern digital electronics. Shannon's thesis has been described by some as the most important and most famous master's thesis of the 20th century. And it was not simply an elegant theoretical connection, actually, right? Shannon was actually providing the design principles that would make the creation of digital computers possible, an essential element for artificial intelligence that we see today, right? Now, what makes this insight particularly significant is that Shannon understood how electrical circuits could implement logical operations, right? Turning abstract concepts into physical reality. And this realization enabled the leap from theory to practice, allowing the construction of machines that could manipulate symbols following logical rules, the foundation of any artificial intelligence system. So that paper was groundbreaking, but his most famous contribution, however, came in 1948 with the publication of the article, A Mathematical Theory of Communication, I think published in the Bell System Technical Journal. So in this pioneering work, Shannon not only coined the term bit, short for binary digit, as the fundamental unit of information, but he also developed an entire mathematical theory to quantify, transmit and process information. It was a true conceptual revolution. Before this, information was a vague and qualitative concept, and Shannon was able to transform it into something measurable and mathematically manageable. He introduced crucial concepts like entropy, right, which measures the uncertainty of information or the information content of a message, redundancy, channel capacity, establishing the fundamental limits of communication in the presence of noise, right? These mathematical concepts have become essential, critical to modern AI, right? How? Well, if you take the example of machine learning, right? Modern machine learning algorithms rely on reducing uncertainty, entropy, right? Natural language processing, probabilistic models of languages use information theory to assign probabilities to sequence of words and characters. Data compression. Compression techniques crucial for handling the large volume of data needed to train AI systems derived directly from Shannon's principles. Right? Information encoding. So modern AI systems effectively represent and transmit information through a process guided by the principles of information theory, right? And that's where sometimes the comparison with Turing comes into play, right? So while Turing was asking, can machines think? Shannon was asking, can we efficiently measure, transmit and process information? And these two questions, complementary to each other, define the conceptual pillars of artificial. So where is the connection in terms of being interdisciplinary, right? So during his undergraduate career, Shannon found time to take an elective class from the Department of Philosophy, and that is what would lead to his very first groundbreaking paper. Philosophy 33, Introduction to Logic, was the elective, and it taught students the general principles of both inductive and deductive logic. Students will learn how to break down and diagram paragraphs like they were math problems, right? And it was in this class that Shannon was introduced to the work of philosopher George Boole. Boolean algebra, as you know, right? It's a system of logic in which statements are given values 1 and 0 with a true statement written as 1 and a false statement as 0. And statements can be considered together with conjunctions such as and, not, or, right? And anyone who has done any sort of computer programming will immediately find this familiar. So today, all programming languages use Boolean logic as a foundation, but when Shannon first learned it, it was his elective philosophy class, not in engineering. And hence, we need to give credit to philosophy for some of the groundbreaking achievements in the field of artificial intelligence that we see today. Well, thanks a lot for watching. I hope you liked the episode. I will see you again next week.